Hi everybody, welcome back to this new WeeW tutorial for the STM32F1 timers, and this time we are going to create a driver for the servo motor. And we do have a normal servo motor which is controlled by position, as I will do here. So as soon as I move my potentiometer, this one will smoothly follow up the direction that I'm putting. And there's a different servo motor, which is the continuous servo motor, which will keep running. And this is like this one. So you can see. Okay, so we are going to play with both of them. And you see here, this servo motor is going in one direction. And I made a small program. So when we change a little bit here, so if we go on this one, it will change the direction. So you see, it can change the direction as we want. Okay, so if you would like to learn how to create a driver for a servo motor, and both of them, the normal one with a quite fixed position and the continuous one, just stay tuned, follow this episode. And finally, we are getting to the practical and interesting part of this tutorial. So in this time, we are going to use a timer to drive the servo motor. So as usual, the code is available on GitHub. Just follow this tutorial. You can download the code and understand it later on. We are going to use only C as a language, and the program that we are going to use for coding will be the KL version 5. Finally, this is a little bit intermediate, as I highly advise to view the previous 3 videos so you can have a really good understanding on how the timer is working. For the hardware, we are going to use today the STM32F1 based board, which is the aka Blue Pill, a 2 potentiometer, 1 servo motor, normal one, and another continuous servo motor, so because they do have 2 different ways to use. And finally, 4 AA batteries, which will give us around 5 volts. Then, from the tutorial perspective, first of all, we are going to understand how the servo motor operation works. After that, we are taking a look on the continuous servo operations, which are a little bit different from the normal one. After that, we are going to review the circuit setup. Then we will code the function for the servo motor driver. And as we have created in the previous tutorial, how to the PWM function, that will be quite very easy and straightforward. Finally, we are going to build the continuous servo motor functions. Okay, let's jump and understand how the servo operations work. So first of all, we do have the servo motor. It's very commonly used with Arduino. So this one can rotate. It depends on the model, but this model rotates to 180 degrees, so 90 degrees in each direction. But you can have some servo motor that are able to have the 360. And the speed is quite not that strong, so it's 0.1 per second. And the voltage supply is between 4.8 and 6 volt, and I really advise you to use an external source for supplying this servo motor. For the connections, it depends on the colors, but usually there is 3 wires, one for the PWM or the signal, and a VCC and the ground. So usually the common one that you have with the Arduino, they have the orange for the PWM connection, and the red wire will be for the VCC, the brown for the ground. Finally, to drive the servo motor using a PWM, you have to use a PWM period of 20 milliseconds, but driving it, the position itself is between 1 to 2 milliseconds. And here there is a little bit of trick. It depends on the origin of the servo motor and also what type of servo motor. But after having some tests, I found that it's between 0.4 millisecond and 2 milliseconds. So it depends on the origin and on the servo motor itself. Okay, so for the continuous one, what we do have here, the continuous servo motor is a servo motor that rotates forward and backward, and instead of moving a single position, it's just rotating. And you do have an RPM going from 110 at 4.8 volt to 130 RPM at 6 volt. Voltage also is same as the normal servo motor, between 4.8 volt and 6 volts. For the connection, exactly same. You will find the same colors and same thing for the servo motor that there is for the Arduino. But for the driver position, it's also same. But here there's an important thing. When you put it at 1.5 millisecond, the continuous servo motor will stop. Less than 1.5, it will run in a speed forward, and more than that, it will go backward in the different speed. So it's a clock direction or counterclock direction. Okay, so now we have an idea how we understand the difference between these two servo motors. Then let's take a look to the circuit. So we will have our STM32F1, and we are going to connect the potentiometer to PA1 and read the value, and also connect the potentiometer to PA2 and read the value. So that the connection we have seen a lot when we went through the ADC tutorials. And then we will have our battery delivering around 5 volt and the ground. And there's a very important step that you must do. You have to connect the STM32F1 ground to the battery's ground. This is extremely important step, and be careful about the wiring. After that, we are going to connect the servo motor to the 5 volt and the ground, and then we are adding the PA8 to the signal pin. Then we were also going to connect the continuous servo motor, same as the normal servo motor, to the 5 volt and the ground, and finally connect the PA9 to the signal of the continuous servo motor. Within that point, we are able now to have a control and to drive a little bit these two servo motors. Okay, so now we just have to go start coding and see the result. So this is our initial code. So what we do have here is the initialization of the ADCs for the readings. So what we have here, we are going to use this variable, which is the analog read, which will stock both variable of the potentiometer, and then the average one. And I will be the variable for counting how many times you are going to read. And after that, we will be using these two variables. The degree is to control the servo motor degrees position, and the speed is to control the continuous servo motor position. And now, so here we are going to take the SysTick init, will be used in the ADC init. So we are going to initialize the ADC1 for the pin A, for the port A pin 1, and the ADC2 for the port A pin 2. After that, we are going to initialize both the analog read, and we are going to read 50 times the value. So we are going to read 50 times the value for both of them. And this one will be averaging the value, so we don't have a lot of noise in our readings. Okay, so this is our first step. And let me also show you the circuit that we do have prepared. So this is our first potentiometer connected to PA1, and the second potentiometer is connected to PA2. This is our battery pack composed of 4 AA batteries, and we do have the yellow one, I hope you see it a little bit, is then the ground, where the red is the 5 volt. This is the servo motor is the normal servo motor, where this one is the continuous servo motor. We do have here the connections coming from PA8 and PA9, and here the important connection between the ground of the STM32F1 and the ground of the battery. Okay, so let's start coding and preparing the code to drive the servo motor. Okay, so let's go here and start this one. So what I'm doing here, I'm not only averaging, because I'm reading 50 times and dividing by 50, which is normal. But after that, what I'm doing, I'm putting it multiplying by 180 and dividing by 4000, and this will give me a value between 1 and actually between 0 and 180. So what we are going to do after that is it's really simple. So let's take the degree, and the degree will equal, and this is the PWM degree that will be converted. So we are going to use as a baseline 400, plus we are going to use this one, this analog read value, and here, and we are going to multiply this one by 11. Okay, so this will give us 400 plus it will be from 0 to 180 multiplied by 11, and this will give us to the full round of 180. Then it's quite very simple. We are going to use the function we created in the previous tutorial, the PWM micro, and that will be, we are going to use the port A, the pin number 8, and from the PWM period, we are going to use 21,000 like this. And after that, we are going to add the degree. This is the degree that we want to have. Let's save, build, and see what's going on. Okay, so far, no error. Let's put this one here and load the code. And after that, I have to activate so the battery is okay. So let me start moving. And you can see it's really sensitive. So this is the maximum. And I'm moving to the other side and it goes there. It's quite going as smooth as I'm moving here. And you can see now we do have a good driving for the normal servo motor. Okay, so let's put the whole thing here in a function. It will be very simple and easy peasy. So we go here and I prepared a place for the function. Let me make a little bit bigger so we can see it all together. So let's create, we are going to provide an output and I'll explain. So we put servo and we call it the 180. So this is servo that will go for 180 and it will be in degree. The inputs will be the char for the port, which port we would like to use, char also for the pin, and finally the int for the degree that we would like to add. Okay, and the degree will be from 0 to 180. Okay, so let's go here. And the first thing we need to check, so if my degree is greater than 180, I don't want to have something more than 180. So what we are going to use here is to say, okay, we return a 0. Okay, and we can close here. And after that, what we can put is we use the function, so or put int, and let's call it degree PWM to have more meaning. That will be the PWM one, so equal 400 plus, as we put it previously, the degree multiplied by 11. Okay, I have chosen 11. You can maybe choose 10 to have the maximum pass, but it depends on the servo. So you can play a little bit and see how it works. And after that, we just run the timer function that we have created. So we go through PWM here. Let's copy it because I'm easy. So it's simple here. So it's micro, this one. We put it here, PWM and micro like this. And what we need to put then, it will be the port and then the pin. And after that, we said to 21,000. And finally, we have to put here our DEG PWM. Okay, so we do have the function quite good. And we are going to return, if everything goes well, return a good one. So we have a good position. Okay, that was perfect. So let's take this function to the header like this. And let's go to the header here, not the message for header, but timer header. And let's add this function like this, and let's write it here. So instead of doing this whole thing again, what we can do is simply bring our function again. Let's remove the char. The port is PA. The pin is, we said pin 8, and the degree will be the average analog here. That will be my degree. Okay, so let's save, and yeah, correct this one first. Save build to see if there's a problem. Yeah, the warning is coming because I should add, if I go here, I should add one extra new line, and I should be good now. Yeah, let's build and take a look, and let's see how it's going. Smooth and perfect. You see, so we do have a tight control degree by degree on this servo motor. Okay, so we created a servo motor. You have seen how easy it is. Now we are going to go to the next continuous servo motor and actually create two functions. Okay, so let's go now and start working on the continuous one. And for the continuous one, if we take a look to the analog read that I'm averaging here, so I'm dividing by 50 to have the average, but multiplying by 100 and dividing by 4000. This is happening because I would like to have a value between 0 and 100, and that will be the full speed. And so actually the continuous servo drive can go in two directions. The direction that is, the speed is backward or forward. So let's go first and check for the backward one, and let's create one. So we are going to use speed is equal, and we have to go for 1500 minus, and this is 1500, the PWM at 1500 means it's stopped. And then we are going to multiply 8 by the average speed that we find here. Okay, so this is what we are going to use. And after that, we just exactly can copy the same thing as this one. So we just almost can copy the same thing. But instead of putting the degree, we just put the speed. And let's put this one here, and you will see what will be going on. I'm not putting the port and pin. I'll be putting here PA, and that will be PA9. Okay, here we should be good, and we should have quite a very quick servo speed, continuous servo speed to work. So let's build and see what's going on. So far so good. Let's load our code. So let's make this one a little bit smaller for the beginning to see if everything goes well. So let's load it and let's play a little bit to see. And you can see that it starts turning. So let's make the picture bigger. So let's see it. You can see now that it's working, and you see the speed going and going and increasing. Yeah, and until we reach the 100%. Okay, that's perfect. But now what we want to do is also to create the other one to go in the other direction. To go for the other direction, let's put this one like this, and we just can copy, and you guess it already, I guess. Instead of putting 1500 minus, we just put a plus. And let's save, build, and we can run here, and you can see that it goes in the different direction now. Okay, so let's pack the whole thing together and work with it. So let's go back here and start to build a new function. Let's call the first one char servo speed. and this will be the counter, the clock direction, and what we need as usual, the char for the port and also the char for the pin. Then finally we would like the int for the speed. Okay, even we can use a char for the speed. Let's go back here and start creating this. So we need to make a test as usual. If speed is greater than 100, no sir, we don't want it. So we just return a -1. No, actually we return a 0. And after that, what we need to put, so we call int speed, and you guess I'm adding here the PWM because it's the PWM speed, actually speed PWM, and this one will be equal 1500 minus speed multiplied by 8. Okay, and that was the division I found that will make the right way of the speed increase. And finally, we just put exactly the same one here. The only difference is how we change, instead of a degree speed, a degree PWM, it will be speed PWM. Okay, and probably you guessed about what will be the next one. This one will be the CC, so the counterclock direction, CCD, and that will be a plus here. So let's copy this one and let's close this one. We don't need it. We add here, we add again, and what we need to do is the counterclock direction. So let's play a little bit. So we do have now a very nice set of things. So let's test it first. So instead of putting all this, we can simply put this one, and for the port is here, we said it's a PA, and the pin that we would like to use is a 9, and the speed is this speed that we would like to put. Okay, perfect. So let's try the clock direction. So build. Okay, we do have 3 warnings, which is normal, so this one is okay. I guess this one, okay, and the missing return, I need to add this return here, so we have a clean functions. Okay, and do I have space? Yep, a new line, I mean. Yeah, 0 error, 0 warning. Okay, so let's play quickly with this. Okay, that's working. So let's run it now. So it's running here in this direction, and if I put the CC one, so and save build, and it went in a different direction. Perfect. So let's play a little bit and do a small change. So let's put here a condition. So if, let's put if not here. So if this one, not this one, if this one here is greater than 90, then what we would like to have, let's put, so we will be in counter in CCD or counterclock direction, and let's put this one here, else we can put this one, and we are going to use the clock direction like this. Okay, let's play a little bit and see what will happen. Okay, so let's, and if we go here, you can see that the direction change. It's quite nice and interesting. So let's stop this one. Yeah, it's almost, why it's not stopping? Probably this is, yeah, this is a good example. I think this is not stopping because we may need to add a little bit more here than 21,000. This is a test because it depends on the how the servo is built. So let's try to do it. It's still running actually, and let's check just a moment. Okay, why this is still keeping. Okay. Got it. Yeah, so you can see here now it's working. It's more about how you have to set up this to variable. I think 21,000 is enough. Yeah, 21,000 and 21,000. Perfect. Okay, that was great and perfect. So hope you have enjoyed this tutorial. See you soon and let's have a good view. Bye.